Am I audible now?
Morning. Yes, sir.
Morning. Yeah, thanks. Okay, thanks for giving your time. I understand this is Sunday, but yeah, thanks everyone for joining initially. Okay, and thank you very much. Okay, so today, this is a webinar for exploring the monitoring setup for Kubernetes cluster actually. So before doing that, uh, let me introduce myself. I'm Shiva. So I have overall 8+ years of experience in IT. Initially, I have started my IT journey as a developer, especially in a Spring Boot developer, and then I have moved to DevOps. Okay, and yeah, that's a short introduction from my side. Okay, so now before that, I want to first explain the architecture diagram of monitoring setup. Okay. And then we will be doing some practical session on that particular setup actually. Okay. So let me share my screen if I have permission. 1 second. Or I need, yeah, I have permission. Let me share my screen. Okay. I hope my screen is visible, right? So let me go to some paint to draw a diagram. So let me go here. Okay. A small amount of Kubernetes knowledge is necessary. Okay. Please do remember that. Okay. A small amount of Kubernetes knowledge is necessary for this webinar actually. Okay. So as a prerequisite, what is required in order to uh, do practical in this course is, let me put it here, the requirements. You need some EKS cluster, or not only EKS cluster, whatever the cluster you want. Like it might be the AKS cluster, it might be the GKE cluster. It should be some Kubernetes cluster. You should have that particular cluster. Okay, that's a. I'm taking here as EKS, which is provided by uh, Amazon. Okay, so I'm taking this as a source of truth for this particular lab and session today, actually. And you require some installations to be done on your machine, like kubectl, and Helm need to be done on your machine, Helm, and few other things that are required. If these are mandatory tools, and other things, if you want, you can install, but for monitoring like KNS and all, if you do not require, you can use that particular tools. Okay, these are the prerequisite tools that should be there. And you also need to have an AWS account. That is main thing, right? So AWS account is mandatory. Okay. Without this, you cannot create EKS cluster, right? So it might be the AWS account for EKS, Azure account for AKS, or Google Cloud account for GKE. Okay, whatever. Okay, whatever the Kubernetes cluster. I'm taking it as example of EKS. That is why I require an AWS account. Okay, these are the prerequisites that are required for this particular session. Okay. So let me put some heading to this particular session actually. So this particular session entirely deals with monitoring Kubernetes cluster. Okay, monitoring Kubernetes cluster with Prometheus and Grafana. Okay, so Grafana. Okay, now what I can do is uh, some heading type of thing. Okay, so that's the thing actually. So let me move this little bit. Let me arrange them actually as a prerequisite. These are required. Okay. So my session will be going something like this. Let me list out how my session goes. First thing, as a first place, we will be having some architecture diagram explanation. And as a first place, we are going to have some monitoring architecture diagram explanation. explanation. Okay, the second part, you will be having some theory concepts. Theory concepts. What is instrumentation? Such kind of theory concepts will be there. Okay, and you are going to have practical session at the end. And if you have any Q&A, we will be having Q&A. Okay, questions and answer session, Q&A session will be there at the these are the partitions of our entire session today. Okay, so let me first deal with the architecture diagram of our monitoring setup for our Kubernetes. Okay, please do remember before starting, I have already created an EKS cluster because EKS cluster itself takes some amount of time, right, to be created, right? So before starting the class, I have created the EKS cluster. Okay, that's a small note I want to give. Okay, so what is the architecture diagram here and how the architecture, how the various components of this Prometheus and Grafana will be integrated together to monitor our Kubernetes cluster or whatever. It can monitor various things actually, not only Kubernetes cluster. Let's first discuss that architecture diagram. What are the components that are involved first in Prometheus? Suppose let's take this as Prometheus server. Okay, this is let me take this as our Prometheus server. This is our Prometheus server. Okay, where we have installed Prometheus. Okay, so now let me go here and let me take this one as Prometheus. Okay, this Prometheus server contains three main components. Okay, this Prometheus server contains three main components that need to be there actually. First component that this Prometheus server contains is a retrieval component. Okay, what is this retrieval component? I'll tell you, but yeah, first let me list out the components involved in this. Okay, this is something called retrieval component. Okay, so let me uh, write something like this. Retrieval component. Okay. Okay. The second component that it contains is time series database. So it contains some database, and the data in that particular database will be stored in the form of time series. Okay, so it contains TSDB. Okay, that is called something called time series database. Okay, it contains time series database, something like this. TSDB. Okay, so this is something called database. Okay, so something like this. Okay, and the next part, what it contains HTTP server. It contains HTTP server where some other tools can get the data, where it exposes, the Prometheus exposes some HTTP APIs so that other tools like Grafana or any other tools can collect the data from this Prometheus. Okay, it contains this HTTP server. Okay, something like this. Okay, this is the HTTP server. Okay, now it contains this Prometheus as a Prometheus server. There are three main components involved in the Prometheus. One is retrieval component. The second one is TSDB. It's a database. And the third one deals with HTTP server. That means it Prometheus exposes some APIs to which other tools like Grafana can connect and get the data and show that data as a visual in a visual representation. So that's what we'll deal with the Grafana at later point of time actually. Now let's deal with each of this component on this Prometheus server. Okay, what is this retrieval component and what it does? The main functionality of this retrieval component is to collect the metrics from various sources. Okay, the main functionality of this retrieval component is to collect the metrics from various sources. What are metrics? Metrics means the CPU utilization, memory utilization, the understanding of the server or whatever the component you take. Suppose you take the MySQL, how much amount of data has been stored, how much amount of bytes has been network bytes has been come into the MySQL database to be stored actually. So such kind of metrics information will be collected by this retrieval component. Okay, now let's me take this. We how the retrieve like please do note that Prometheus understands only PromQL language. Okay, I'll tell you that. Okay, what will be there? Suppose I have some servers or databases that need to be monitored. Something like this. I have let me write it here. I have some servers, some virtual machines or servers. I have MySQL database, and I have MongoDB database, Mongo, MongoDB database. Okay, so something like this, we have something like servers, MySQL, MongoDB, or whatever, PostgreSQL, whatever we have, we have something that need to be monitored by the Prometheus. They are running, suppose if you take MySQL is running inside the server. If you take MongoDB is running inside the server. Okay, so something like this. So we have some components that need to be monitored in my company. Okay, so how to set up these monitors? Okay, so here what you are going to do, you will be installing some exporters. Okay, Prometheus give you some exporters. Suppose if you go to if you want to monitor the MySQL database, it gives MySQL exporter, MongoDB exporter, so node exporter. The server, if you want to monitor servers, you have node exporters. Okay, you are going to install node or whatever exporter you want on that particular server where these components are running, where this MySQL is running, where this MongoDB is running. You are going to install the respective exporter. Okay, so let me write that here. Okay, you suppose, let's think this is the server or MySQL, whatever it is running, something like this. Inside this three things are running, and you are going to install exporter on top of this, the respective exporter. If you are trying to monitor MySQL database, you are going to install MySQL exporter. If you are trying to monitor MongoDB database, you are going to install MongoDB exporter. If you want to directly monitor the servers or EC2 machines, whatever virtual machines, whatever you want, you are going to install node exporter. Okay, that's the thing actually. So I'm going to install a component on this server, something called node exporter. I'm taking some example of node exporter, something like this. Okay, this is some software I'm going to install, which is given to me by Prometheus actually. So something like this. Okay, this is something called node exporter. Okay, let me write it here outside because I cannot write inside actually. Okay, so this is something called node exporter. Node exporter, something like this. Okay, now what this retrieval component does, retrieval component will collect the metrics from this node exporter of MongoDB or whatever the component you want. Okay, suppose this retrieval component collects the metrics from this particular exporter. Okay, something like this. Okay, here, if you want to, I've already told you, if you want to monitor MySQL, you are going to install MySQL exporter on this particular MySQL database on the server where you are going to install MySQL. Actually, so you are going to have the exporter here. And what this exporter does is whatever the collected metrics from this server, it will be exporter will convert into Prometheus understandable format, because here Prometheus will only understand some language. Okay, it does not understand all the languages actually. Prometheus will only understand PromQL language. So this exporter will collect all the metrics from the server, and this exporter converts those metrics in the Prometheus understandable format. And the retrieval component of the Prometheus will be connecting to that particular exporter and gets all the and collects all the metrics from that particular exporter actually. So this is how the retrieval component does. For the node exporter, sorry, for the servers, MySQL, DB, MongoDB, for example, I've taken. Okay. So any questions here, please, before doing this, before going further, any questions anyone has? Or all clear? I want to hear you from people. If you are unable to talk, please put the message in chat. Or do you want me to explain one more time?
So this node exporter export data in real time. Where do you keep all the
Yes, node
matrices?
exporter. What I did not get full question. Can you repeat that?
My question is like node exporter, like it export all the matrices, right, of
Yes.
the server. So
Uh-huh.
the matrix will be continuously generating. So where does
Yes.
it store it?
It does store on the same machine, right? The node where the node exporter is there on the same machine, it is going to store. And once the retrieval component retrieves the data, that will be there will be some log rotation setup that will be happened on this server, and that log rotation setup will be cleaning the stored data, because once that retrieval component retrieve the data, it does not it should not contain all the data, right? So something like that it is going to do.
Okay, okay.
Yeah. All clear for everyone? Can you please put the message in chat? I want this session to be interactive.
Yes, clear.
Yeah, thanks. Okay, the next part. Since there are some things which will be which will be lived for small amount of time. Suppose, let's take, if you people understand some in AWS there is something called a service called Lambda. Okay, that will be executed a limited amount of time, for 1 second or 2 seconds, and it will be going off. Okay, so there are some jobs that will be executed very short amount of time. Okay, so if you want to collect the metrics from such kind of jobs, that those are something called short-lived jobs, whatever. Okay, so if you want to collect the metrics from that particular kind of jobs, it's very tough for the Prometheus to collect the metrics from the for such kind of job, because before retrieving the before Prometheus retrieving the metrics from such kind of short-lived jobs, the jobs will be executed and completely signed off, right? So Prometheus people has given some component called push gateway, okay, in order to collect the metrics from the short-lived jobs. Prometheus people has given some component called push gateway. Okay, something like this. Let me have it here. This is something called push gateway. Okay, so this is something called push gateway. Something like this. And whatever the short-lived jobs are there, like Lambda function execution, like Kubernetes jobs execution, whatever the short-lived jobs are there. Okay, the short-lived jobs, once they are executed, let me first write that one. Let me write, these are the short-lived jobs that are going to be executed. Short-lived jobs, something like this. Okay, whenever the short-lived jobs are executed, they will push metrics to this particular push gateway. Okay, they will push metrics to this particular push gateway, something like this. Okay, because when the Prometheus will retrieve the metrics in regular intervals of time, you can configure that for 5 seconds, for 15 seconds, for 20 seconds, for every 20 seconds, something like that, right? So when suppose let's think Prometheus is going to retrieve the metrics for every 15 seconds, right? Before that, suppose one job has been scheduled in the short-lived jobs like Lambda function or the Kubernetes job that has been executed only for 5 seconds. Then Prometheus is going to miss that metrics from that particular job, right? So in that case, Prometheus people has given for us they have given something called push gateway, and whenever the job is being executed, that job is going to push the required metrics for this push gateway. Okay, the metrics will be there as part of this push gateway, and the retrieval component of the Prometheus server will collect the metrics from this particular push gateway. Okay, such how like that it is going to do. Okay, because for the short-lived jobs, the same reason again, they are going to live for a short amount of time. If the before retrieving the Prometheus retrieving the data from the short-lived jobs, the short-lived jobs may go off, sign off, and Prometheus, there is a chance that Prometheus will be losing the metrics from the particular jobs, right? So what the short-lived jobs does when they are completed, they are going to push the metrics to the push gateway, and the push from the push gateway, the retrieval component of the Prometheus is going to retrieve the data. Okay. Okay. That's any questions with regarding this push gateway and short-lived jobs? Anyone?
No, no question.
Okay. Thanks. If no questions, fine. Let me also deal with the Kubernetes. This is something called short-lived jobs like Lambda functions or whatever. These are a servers, MySQL database, and MongoDB database. We also have Kubernetes cluster that need to be from that Prometheus need to be collecting the metrics from. Actually, suppose let's think this is a Kubernetes cluster, something like this. This is our Kubernetes cluster, which is there. Okay. So this is the Kubernetes cluster, okay, and we will be regularly creating some services. We will be regularly removing the services. Okay, this is our daily activity as a DevOps engineer. Whenever the requirement comes, we are going to add the services. Whenever the requirement goes, we are going to sign off the services. That means we are going to remove the services, right? How the Prometheus can understand from what services the metrics data need to be collected from. Okay, how the Prometheus should understand the metrics data need to be collected from. If you statically, there is some config file for the Prometheus, there is some config file that need to be given. Okay, there is something called Prometheus.yaml file, .yml file. Okay, you can statically give from these particular services. The Prometheus has to collect the metrics from actually in this Prometheus.yaml file. You can statically give from these particular services, the data need to be collected. Suppose tomorrow the service has been removed. Okay, Prometheus still searches for that particular service. Actually, this is the reason, because we are regularly removing the services, adding the services. Because of this reason, we in IT industry configure service discovery as a mechanism to collect the metrics from the Kubernetes cluster, because whenever any service is added, automatically Prometheus, no need of changing again and again the Prometheus.yaml file to collect the metrics. Automatically that service will be discovered by our Prometheus server. Automatically from that particular service, our metrics will be collected by the retrieval component. So that's a service discovery that need to be that will be configured as part of our IT people, as part of our Kubernetes cluster actually in the industry. Okay, this Kubernetes service discovery. Okay, so service discovery will be configured. Let me write full name. That's a service discovery. Okay, so when you configure this service discovery in your Kubernetes cluster, whenever you create a service, automatically something like this, there will be a one particular service, something like this, and your pods will be under that particular service. Let me take these two particular pods actually. something like this. Let me take something like this and these two pods. Then your data will be collected something. Your traffic will be going something like this, right? So whenever this service is added, the Prometheus automatically will understand when you configure service discovery. Prometheus will be automatically where to configure Prometheus service discovery in this Prometheus.yaml file, right? When you configure this, Prometheus will automatically understand that this service need to be discovered and the metrics also need to be collected from this particular service actually. So the who will collect that? Again, the retrieval component collects the metrics from this particular service discovery that is being configured for this particular Kubernetes cluster. Okay, that's a small example of service discovery that need to be, because everyone uses service discovery nowadays in our Kubernetes cluster, because statically configuring the services in order to collect the metrics from that particular Kubernetes cluster is very tough and error prone actually. Okay, so that's the service discovery people use actually now. Whatever the data that is collected by the retrieval component of Prometheus will be stored as part of this time series database. Okay, whatever the data that is collected by the retrieval component of the Prometheus will be stored as part of this time series database. Okay, and this time series database contains all the data that is being collected from different sources, like use from the exporters, from the push gateway, from the service discovery of Kubernetes, and all this data will be there actually. Okay, and you also need to understand Prometheus will only understand one particular language. Prometheus will only understand one particular language, that is PromQL. Okay, Prometheus will only understand one particular language, that is PromQL. Whenever Prometheus is collecting the metrics from that particular sources, the Prometheus source of truth is PromQL. You should export that particular metrics only. Like here, node exporter, what it does, it converts the collected metrics from the servers into a PromQL language, and the retrieval component collects the metrics from the node exporter, the PromQL metrics from the node exporter. So from all these components, that retrieval component will be collecting the metrics in the language of Prometheus, that is PromQL. Okay, that's it. Now, all the data is there as part of this time series database. All the collected data that is there as part of this time series database. Now, right? Now, Prometheus also contains something called expression browser, where you can query the data and you can view the graphs inside the Prometheus dashboard. Okay, I'm going to show you in a practical manner, but that is not that much user experience. That UI is not that much very good actually, and Prometheus is not providing very good UI for us in order to deal with, in order to create the graphs and the dashboards, right? So what people uses in real time, they will be installing something called Grafana, something like this in one particular place. Okay, they will be installing something called Grafana. It's a outer component. That's a this is a Grafana. This is something called Grafana. What this Grafana does? Grafana now, where is the data? Data is there entirely with the Prometheus now. It collected all the data from this particular sources actually, from push gateway, node exporter, services for Kubernetes, and all these things. And the Grafana, what it does, it connects to this HTTP server. It connects to this HTTP server. Okay, something like this. And gets all the data that is there in this database. And HTTP server will be getting the whenever you call it, Grafana is going to call the API in the Prometheus and gets the data from this database. And Grafana, you can create very good dashboards and graphs in this Grafana dashboard. And we are going to see the practical. The Grafana here is going to collect the metrics from the Prometheus. That's what you need to understand. Grafana is going to collect the metrics from the Prometheus actually. Okay, because Prometheus contains all the data that is being collected by the retrieval component of the Prometheus. And this one, we call it as data source in Grafana. In Grafana terminology, we call this Prometheus is a data source. From where the data is there inside the Prometheus, right? So Prometheus is something called data source, something like that. Okay, that's a data source. Now, the next thing, with the help of Prometheus also, I've just put the monitoring, but yeah, let me explain this one theory concept, no problem for me. Okay, in Prometheus, you can define some rules in this Prometheus.yaml file only. Okay, you can define some rules actually. Okay, what rules that you are going to define? You can define saying that whenever some service, some application goes down in the Kubernetes cluster, application goes down in K8s, one second, sorry, cluster, trigger and alert. Trigger and alert. Okay, you can define some rules, something like this. This I've just written in English word, and the rules, the rules you need to define in the YAML format. Okay, so this rules you can define in this Prometheus .yaml file. Okay, if you define this rule, whenever any service goes down, okay, something like that, in the defined role, I have particular user management service. So let me think, I've defined some rule in this Prometheus.yaml file. If user management service in the Kubernetes cluster goes down, you need to trigger an alert, something like that. I've defined in a YAML format, okay, in this Prometheus.yaml file. Okay, I've defined that rule. What happens is whenever this rule is been, whenever my user management service is down in my Kubernetes cluster, there is something called alert manager. There is something called alert manager that will be there. Okay, this is something called alert manager. Okay, this is alert manager. What this alert manager does? Okay, this whenever this condition satisfies, whenever my application goes down, Prometheus is going to send the alert to this particular alert manager. Okay, Prometheus is going to send the alert to this particular alert manager. Okay, something like this is going to trigger an alert for this particular alert manager. Okay, for this alert manager, there is some config file where you need to define where the alert need to be sent to. Okay, like whether you want to send the alert to Slack channel, okay, whether you want to send the alert to the Teams chat, or whether you want to send the alert to the email saying that application is down, you need to configure that. Okay, then this alert manager can send the alerts to respective configured component like email, like pager duty, like whatever, the Slack channel. Okay, something you can define multiple sources to send the alerts to. And this is something called something, let me write, it can send multiple places, email, and this is something called Slack, and this is something called pager duty. Something like this. So it can send the alerts to multiple places. Okay, something like this. Okay, so whenever Prometheus sends the alert to alert manager will send alert to this particular Slack page activity, or whatever you can configure, and you will be able to know that the application is down in that particular Kubernetes cluster actually, and you are going to act on that, or you are going to work on that to solve that particular problem actually. Okay, so this is the overall architecture diagram of our monitoring setup actually. This is an alerting actually. So this is also just as a for your understanding, this also comes actually. So this is an overall architecture of monitoring with our Kubernetes cluster with Prometheus and Grafana. Not only Kubernetes cluster we have seen some people node exporters and all whose gateway or whatever. The architecture diagram is this one actually. Okay, any questions, please? Is that clear for everyone?
Yeah.
Okay.
Sir, like, is this same will be applicable for all kind of cluster? Like, if you are setting up in the what we say this on-prem server, it will be same
Yes,
there too.
same. Yes. Because these are universal for every cluster.
So, just like Prometheus is a scraping, like it scrape the
Yes.
metrics and push to the Grafana. Do we have another tool like Prometheus, or it's current only we
Yeah,
use this?
we have many tools in the market like Prometheus. We have this one called a data dog. Okay, it collects both the logs and the metrics. We have many tools in the Grafana Loki, and we have something called AWS has released some new thing that is called container insights. Okay, such kind of many things are there in the market, not only the Prometheus actually. Okay, so
But Prometheus is like widely used, right?
widely
Okay.
used. Yes,
Okay.
most of the people uses Prometheus.
Okay. Thank you.
Yeah. All clear, please. All clear. Can you put some message in chat? I think yes. Okay. 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 So I want to just generalize some theory concept actually. Suppose, yes, clear. Oh, thank you. Thanks for that actually. Now, let me go to my Amazon. Okay, let me go to my Amazon.in. Okay, AMAZ Amazon.in. Okay. Suppose I have many items here. Okay, I am going to have many items here, actually, something like this. Okay, there are many things that are there on my Amazon products where I can purchase. Right. What I want to do, I want to collect a metric. I want to collect a metric. Suppose let me take this one. Okay, if I add this item, add to cart, something like this. Okay, let me click on skip. Okay, I want to whenever. Okay, you can see that added to cart. Okay, I want to collect the metric how many number of items added to cart from the application. Okay, these are something called which is not exported by the application. Okay, these are the something called custom metrics, we will call it as. The application should export these metrics. Okay, I hope you are understanding. These are the application level metrics. Okay, so whenever I want to whenever the customers of the Amazon.in application is adding some product to cart, some products to cart. Okay, I want to as a Amazon.in employee, as a DevOps engineer Amazon.in. Okay, I want to collect those custom metrics from that particular Amazon.in application actually. That means how many number of products added to cart per particular minute or particular second, whatever. Okay, per particular amount of time. I want to collect such kind of custom metrics from the application. Did you people understand the requirement? The requirement is clear. What is the requirement? I've just explained is clear.
Yes.
Yes. Okay. What about others? Yes. Right. So, okay. So this is the custom metrics that need to be that deals with the application. Okay. That need to be deals within the application actually. Okay. So in order to collect such kind of custom metrics, okay, from the application level, you need to do some instrumentation. What is instrumentation? Okay, you need to add some code to your application code. Okay, add some libraries to your application libraries so that your application will be exporting the metrics in the Prometheus understandable format. Okay, let me take an example of Spring Boot application. We have some Spring Boot application locally, that is the data store application. This is the data store application. It's a simple API application that we have, Java-based application. It contains two different APIs, I think. It contains two different APIs. One is Host API and one is Get API. You see that this is the application. I want to collect the application level metrics, like how much amount of memory is used by the JVM. This is a Java based application, right? So there will be a JVM component in the Java, okay? Java virtual machine, okay? That how much amount of CPU is being used by the JVM component, specifically by the JVM component, because that's an application level metric. Okay, so for that we need to instrument this application. We call it is, in the Prometheus terminology, we call it as instrumentation. Actually, what is the meaning of instrumentation? Exporting the application level metrics from the application. Application should export whatever the metrics you want, so that the Prometheus collects those metrics and stores the data in the Prometheus database. Okay, those are that is something called instrumenting your application. Okay, that's what the thing is. For instrumenting this application, okay, we need to add some libraries to your application. Prometheus has given you some libraries. If you go to Prometheus documentation for the instrumenting your applications, Prometheus has given you some libraries in order to instrument your application. Okay, for Java, for Go, for Rust. Okay, Prometheus has given you some libraries in order to instrument your application to export application level metrics. Okay, so that's the thing. In this particular, let me deal with the particular application. In this particular application, in order to instrument my application, what I did, I need to add something called micrometer dependency. It is a library that need to be added to this Prometheus, to this application, so that I can export the application level metrics. I can export the application level metrics from this particular application when this application is running in the Kubernetes cluster. Okay, so sometimes you also need to modify your application code, in order to export the metrics. So for example, the number of items added to the cart in the Amazon.in application. If you want to collect those kind of metrics, you need to change your application code based on the library that we have added. So this is something called instrumenting your application to export application level metrics, so that a Prometheus contains the data and you can collect the data from the Prometheus and show in a visual representation in Grafana. Like for this particular, suppose what is the time now? 10:45. In 10:45, these many items are added in the cart by the customers. Out of these many items added in the cart, these many are sold out. Okay, something like that. You can monitor in the Grafana dashboard by instrumenting your application. So instrumenting your application is widely used in industry. Please do remember, people want to collect their application level metrics from the from the applications, actually, by instrumenting their applications. Actually, okay, so that's what you need to understand as a instrumentation of your applications, actually. Okay, any questions anyone has, please? Just any questions? No, logs not. See, logs are different, metrics are different. Okay, logs means whenever your application is being executed, you want to check whether the application is connected to database, whether the data is stored in the database or not, if the database is properly responding or not. So all those things will be there in that particular logs. Okay, logs. It's a text. They will be in the text format. Logs are very useful for developers. So they will be checking the logs and decide how the application is being performed, how the application is been working. Okay, so those are the logs, actually. metrics means it's different. Okay, the how much amount of CPU is consumed by my application, how many number of items added to the cart, out of those cart, how many number of items are sold out. Okay, such kind of things are such nothing but the application. Yes, health or performance of application. Yes, you are right. Actually, yes.
So like when we write YAML for any application, so there we pass like CPU utilization or memory request or memory limit. So for to understand the application's memory usage, we can use this kind of thing, right?
Which one? Which kind of thing?
Like suppose when we write a YAML, we pass na
Yes.
CPU utilization,
Resource
memory
request and
utilization.
limits. Yes,
Huh.
yes, request and
So
limits.
suppose we don't know how much limit this application need. So for
Okay.
that kind of situation, we can use this, right?
Yes,
Application will tell us like
yes.
currently it's using this amount of memory in CPU.
Yes. Then you
Uh,
can increase the limits, whatever
limit
you want.
and
Yes.
request. Yeah, right. Okay,
Yes, you are
got it.
right. Yes. Okay. That's how we instrument your app. That's a concept of instrumentation and collecting custom metrics actually. Okay. That's the thing. Now let's deal with our lab actually. So we deal. Let me. Where is that diagram? Yeah, this is the thing. We have completed our architecture, diagram explanation, and theory. Just have to explain you about the instrumentation and all. And then let me go to my practical session. Okay. Let me go to my terminal. Before that, okay. So I have my Kubernetes cluster installed. If you go here, if you type kubectl get nodes, you see that we have two node cluster. Let me wait. Actually, it is fetching the data. Okay, you see that we have two node cluster which is running since 90 minutes, and the version of the cluster is 1.25. It's a EKS cluster. I'm using the EKS 1.25 cluster. Okay, the creation of cluster you need to do from your side because that takes a lot of time. Okay, now see, I am going to use help to install some things to the Kubernetes cluster because I have in the diagram I have you've already seen we require time series database. So for this time series database, there should be some data stored that need to be provisioned in our AWS account. What we are using is we are using AWS EBS volumes as a data store. There will be dynamically provision. I am using dynamic volume provisioning that will not deal with this particular webinar actually, but it is required for my Prometheus monitoring setup actually. For me, it is required for setting up the monitoring setup for my Kubernetes cluster, but uh, it is not dynamic volume provisioning is not part of this particular webinar. Okay, please do remember that. Okay, for that I am going to use some helm charts in order to install the dynamic volume provisioning. For that, let me go to help here. Uh, See, I need to have few Helm repos to be installed for AWS EBS CSI driver. Why this AWS EBS CSI driver need to be installed first? See, you need to understand why it is required. To see here, we have our time series database. It stores some data. This data has to be stored externally, some like EBS volumes. Okay, in the EBS volumes. So in order to provision this EBS volume of AWS, we are going to install AWS EBS CSI driver. Sorry for that. AWS EBS CSI driver. Okay, the AWS EBS CSI driver I'm going to install. I'm going first. This repo, the Helm repo, is being added to my local repository. That is the Helm repo add command. Okay, let me go here and let me add this one. It is already there. It says already exists. Okay, and you need to install the EBS CSI driver using this command. Helm upgrade hyphen install. This is a release name that we call it as AWS EBS CSI driver, and where you are trying to install in the namespace of kube system. And this is the AWS EBS CSI driver that we have added in the previous command to our local machine, right? So to our local Helm repo. Okay, let me copy this and let me execute this one in order to install AWS EBS CSI driver. Okay. Okay, this is the AWS ESI CSI AWS EBS CSI driver that is installed. If you see kubectl get pods -, where we have installed this AWS EBS CSI driver in the namespace of kube system, right? In the namespace of kube system -n kube -system, something like this, right? So you see that AWS EBS CSI driver has been installed. You can see that we have these are the components of AWS EBS CSI driver. One will be controller, other will be daemon set that will be installed actually not a EBS volumes. Okay, that will be there. It's not rated it is actually, so that's fine. Okay, now let me go here and let me AWS EBS CSI driver is installed and they are in the running state. Running state. You can see that all the things are in the running state. Now, I need to install Prometheus to my Kubernetes cluster. I need to create a Prometheus namespace. We have something called namespaces concept in Kubernetes. So we need to install the kubectl create namespace Prometheus. So I'm going to create a namespace called Prometheus. Okay, just it's a namespace. Okay. Let it create. Until then, let me open my documentation of Prometheus. Okay, namespace Prometheus got created. If you see here, and whatever I want to do is first you just list the namespace kubectl get ns. That's a namespace. NS is a shortcut for namespace actually. You can see that Prometheus namespace has been created. In this Prometheus namespace, I want to install Prometheus Helm chart. You can see that here. Before that, I also need to install this one, storage class for dynamic volume provisioning. This is a storage class that I need to install. Before that, once again, let me go to a particular folder you know to install, or let me copy that path. Yes, copy path reference. Okay, let me go here, kubectl apply -f, and let me put this one, and this is going to be my obsolete path for my what is that storage class. This also deals with dynamic volume provisioning. Okay. Okay, you can see that this is a storage class that we have installed. If you see kubectl get sc represents the storage class. Yeah, you see that here our previous storage has been created, and let me clear the screen. Right now, as I've created Prometheus namespace, I need to install Prometheus to my Kubernetes cluster, and with this helm install command. Okay, let me go here and install. Okay, something like this. Okay, the storage class name. These are helm related commands actually in the namespace. I'm going to in the Prometheus namespace. I'm going to install Prometheus, and I'm -- set. I am setting the configuration in the values.yaml file in the helm chart to the of storage class name to this monitor EBS storage that is we have created just now. This one, monitor EBS storage. Okay, something like this. This is okay. So let me execute this one. I'm installing just the Prometheus, and let me go here. Yeah, Prometheus has been installed. Let's wait for the Prometheus to come up. kubectl get pods -n Prometheus. Yeah, you see that. You see that. You see that whatever the things that have been there. Alert manager has been installed. What is the alert manager in our diagram? Alert manager is a one where Prometheus will be sending the alerts to. This is a alert manager. Okay, you can see that alert manager. Okay, and let's deal with that afterwards. What is kube state matrix? It's color matrix, something like that actually. So Prometheus node exporter, because how many number of nodes are there in my Kubernetes cluster? kubectl get nodes. Okay, you see that. And nodes. How many number of nodes are there? There are 2 nodes in my Kubernetes cluster. That is why 2 Prometheus node exporters have been created to collect the node level metrics from my Kubernetes cluster. Okay, so because you see that there are 2 nodes, that is why they have created 2 pods on that particular 2 nodes. You can see that here. The node exporter will be installed on the servers or the nodes, to collect the node level metrics actually by the Prometheus. Okay, that's a node exporter that has been created. Okay, as Kubernetes contains short-lived jobs, there is a job concept in Kubernetes which is going to be running for very small amount of time. You need push gateway in the Kubernetes cluster that need to be installed. You can see that Prometheus Helm chart is also installing push gateway. Prometheus push gateway. You can see that which the retrieval component of Prometheus will be collecting the metrics from this particular push gateway, right? So we can see that here. And the last part is our actual Prometheus server, where which has all these retrieval component types, series database, HTTP server. That's a Prometheus server. One second. Once again, you see that. Yeah, you see that all my things are being come into running state. And if you see why I have installed the AWS EBS CSI driver, firstly is if you see kubectl get persistent volume PV. This is something called in the there is some storage concepts in Prometheus, that is we call it as PV, persistent volume. Okay, so let's wait for it. Yeah, you can see that here it provisioned the 2 PVs. Alert man. Can you people able to hear me?
Yes. Yes.
Okay. Where is the last concept that we have missed? At what place? PV. Okay. So, okay, you see that here. Where is the PV? If you see that, okay, if you see that, the kubectl get PV got created. It created 2 PVs. This is why we have installed AWS EBS CSI driver to our Kubernetes cluster in order to provision the EBS volumes from the AWS account. You see that it has provisioned. If you go here, it has provisioned 2 EBS volumes. That is this one with the 2 GB size and this one without this one. Actually, you can see that these two are node for the node one. Okay, Kubernetes for node related volumes, and these are the volumes that are provisioned now for because of the dynamic volume provisioning that we have installed AWS because of the AWS EBS CSI driver actually. Okay, so now we have installed Prometheus, and the Prometheus is collecting the metrics. You also need to understand where the Prometheus.yaml file exists. This is a very important file. You need to understand where that exists, and you need to deal with that actually. Okay, the Prometheus.yaml file in the Kubernetes will be there as part of the config map in that particular namespace Prometheus Prometheus, where the Prometheus Helm chart is being installed actually. Okay. All the configuration file of Prometheus.yaml file is set as part of this config map, and this config map is passed as a reference for this particular Prometheus server, so that the Prometheus server will be getting the configuration. Okay, so whenever if you want to change any configuration for the Prometheus, you need to change the config map of the Prometheus so that the configuration will be reflected in this particular Prometheus server actually. So that's how this if you see this, let me copy this Prometheus server config map. Okay, if you see kubectl edit config map -n, let me paste this and -n Prometheus. See, these are all, this is entirely the configuration file. If you see from this particular place, this is entirely a configuration file. You see scrape interval. What is a scrape interval? For every 1 minute, the Prometheus is going to scrape the metrics from the Kubernetes cluster. Okay, all these things are the configuration file that need to be that will be given to the Prometheus actually. If you want to change any like if you want to configure service discovery, okay, you need to change this configuration file accordingly to collect the metrics based on the service discovery. Okay, so that's a configuration file. We need to understand this location. We are going to see in our course, but yeah, this entire thing you need to understand actually. Okay, that's it. Okay, this is the Prometheus configuration file or the config map that will be used by the Prometheus server in order to configure itself, right? So now we need to what we need to do is we need to access this Prometheus server from the dashboard, okay, from the browser. How we can do that? Okay, you need to do something like this. If you go to kubectl get svc -n Prometheus, you need to port forward. Let me come on. This is a Prometheus server. Copy it. And let me go to this particular other tab. If you clear the screen, okay, kubectl port -forward svc slash the service name. What is the service name? Prometheus server will be the service name. Actually, if you see this Prometheus server will be the service name. You go here, the service name, -p. I want to access this port now 8989 : what is the service port that we have? The service port is 80 and the Prometheus will be running on port number 9090. Please do remember that. Okay, so 80 and what's the namespace -n Prometheus, something like this. Okay, what is this? Okay, let me know this. Hmm. Okay, you see that the port forwarding has been started. You can access the Prometheus from the browser using localhost 8989. Okay, let me go to the browser. Localhost 8989. Okay, this is the Prometheus server where it is running actually in the Kubernetes cluster. Okay, it contains all the data, but you can see that. Let me take one PromQL query. Let me copy that 1 second. Let me take one PromQL query and query some data for CPU average. Let me take ports for namespace, some of the rate. Okay, let me go here at the PromQL query and go here and click on execute. You can see that it contains some data, but it is not that much very user experience. It's not that much very good to you cannot create a dashboards and panels and all these things. It's not that much very good if you see the UI, right? So that is why Grafana has been come into the picture. You can see that alerts, you have not configured any alert rules. What I have told you, you need to configure some rules in the diagram. Where is the diagram? Okay, 1 second. Okay, what I've told you, you need to configure some rules so that Prometheus is going to trigger the alert manager and alert actually. So as of now, there are no rules that has been configured. That is why no rules found it is saying. Okay, you can see that all the things service discovery, and you can also check the configuration from this particular place. You can see that here all this configuration from where it is coming, from the config map of Prometheus. Just now we have seen, right? So Prometheus contains some config map in the Kubernetes cluster. Okay, so if you want to change any thing for Prometheus configuration, for like configuring service discovery and the alert manager and the alert roles, you need to change this particular Prometheus server config map. Okay, so that's what you need to. The content of this Prometheus server configuration file is there as part of this particular configuration. Okay, in this particular place actually. Okay, so this is a configuration file, a scrape interval, because that scrape timeout. Okay, scrape protocols, all these things. Okay, so all these things will be there actually. Like that, you can go through all these things: service discovery, rule health, target health, and all these things. You can also check the target health, the metrics collection, and you can see that it is collecting the metrics from the Kubernetes nodes. How it is collecting the metrics using the node exporter and all. You can see that here. These are all the collected metrics from the Kubernetes cluster and the service endpoints. It is collecting the metrics, and these are the targets. See, what are the targets for the Prometheus? In the Prometheus terminology, we call it as targets. Targets means from which place the Prometheus is getting that metrics actually. Okay, here in this case, node exporter is a target. In this case, services are the targets from the Kubernetes cluster. The push gateway is a target for the Prometheus, something like that. Okay, target means from which place the Prometheus is collecting the metrics from actually. So that's the thing. You need to give Prometheus only understand the PromQL queries. You need to give PromQL queries in order to get the data from the Prometheus server. Okay, so like time series database, MySQL only understand the MySQL queries, right? Like that Prometheus is going to understand only PromQL queries. Okay, so that you are going to retrieve the data from the Prometheus data time series database. Okay, that's the thing. Now let's install Grafana and connect Grafana with the Prometheus server. Actually, before installing Grafana, you need to create a Grafana namespace, kubectl, create ns Grafana. Okay. Right. We have a Helm chart for installing Grafana. Let me go here and get the Grafana Helm chart. I don't want to use this persistent. It is that. I don't want to use this. Actually, that's a different thing. Okay, let me copy this Grafana Helm chart command and let me install Grafana. Is that okay? These are all the Grafana Helm chart related commands. I'm saying that here Helm install. This is a release name we call it as, and the Helm chart, this is a Helm chart we call it as. And the namespace, I'm going to install this Helm chart into Grafana, and the set in the value in the Helm chart contains a file called values.yaml file, and in that values.yaml file, the storage class name I'm changing to monitor EBS storage, because we have installed that storage to the Kubernetes cluster, and we are going to enable persistence is enabled display true. Some of the values are changing. The admin password I'm going to change to Shiva with the rate 123, and the service type is going to be changed into load balancer. Okay, that's all the things I'm changing. Or the username is going to be the admin, the default username of your Grafana actually. Okay, so kubectl get pods -n Grafana. Okay, the pods are going to be created in Grafana. Okay, Grafana namespace. Okay, you can see that Grafana pod is running. Okay, we have something called load balancer will be created because there are some types of services, cluster IP, node port, and load balancer, and other types of services such as headless service and all. Okay, kubectl get svc -n Grafana. Okay. You see that there is a load balancer that will be created because we have created a service of type load balancer. What I want to do is you can also use this load balancer DNS from your browser, something like this. Okay, you can go to your browser and put this load balancer DNS, and your Grafana dashboard is going to open. But I just want to use it in another way. One second. Okay, this is a Grafana login screen, but what I want to do is I want to create a record. I am using the Route 53 service. Okay, so this is going to be my Grafana, and I want to do the C name and put something here, the load balancer DNS name and all. And let me click on create record. And now let me use this domain in order to access Grafana. Okay, it takes some time because just now we have added. Okay, let it take some time. Okay, let me first clearly check whether this has been added properly or not. And let's look up Grafana dot traffic dot org.in. Yeah, it has been added and the canonical name is this one. That's fine. You can add it properly. Just we need to wait. That's it. Okay. Yeah, you see that Grafana page is open now with this particular domain. You can also use this domain in your browsers if you and confirm me whether this page is being open. Okay, can anyone confirm? Grafana.traffic.org.in is been opening.
Yeah, it's opening.
Right, so that's the thing. That's how we do in real time also. Okay, we are going to attach this some particular domain to DNS name of the load balancer, and that will be open actually. Okay, now trying. Fine. You can also try in your mobile phones that is going to open it. So that's fine. Okay, the email, the default username is going to be the admin, and the password is going to be the password we have set while installing the Grafana. This is this one. Something like this. The password is going to be this one. Login. Okay, this is the Grafana dashboard, initial dashboard that we will be seeing once you have logged into this particular piece actually. Okay, so now for the Grafana, you need to set Prometheus as a data source, right? So in the diagram, what I mentioned, Grafana will be collecting the metrics from the Prometheus. So this is a Grafana, will be collecting the metrics from the Prometheus, right? So in the Prometheus, uh, you need to configure the dashboard. Okay, you need to click on this, once again, connections, data sources, and you need to click on add a data source. And what is the data source for us here? Where the data is there in the Prometheus, you can see that Grafana supports many data sources: Graphite, InfluxDB, OpenTSDB, Loki, Elasticsearch, Jaeger, Tempo, Zipkin, okay, like that. Many things are being supported by the Grafana in order to access Grafana. These tools will be acting as a data source for the Grafana. Absolutely. What is our data source here? The Prometheus is going to be the data source for us. Okay, let me click on this. The Prometheus. Okay, the Prometheus is going to be added as a data source, and you need to configure that. What is the Prometheus HTTP URL? Okay, you need to, this is the DNS name of the service that deals with the Kubernetes. Actually, if you see a kubectl get ESVC, okay, -n Prometheus. We will also pair here actually. You see that here, Prometheus server is a service name. Okay, Prometheus HTTP://Prometheus server. Okay, dot Prometheus dot svc dot local. That will be the DNS name that you need to configure. You can see that http:// Prometheus server. Prometheus server. This is service name. This is a namespace name that we call it as. This is a prefix. That will be this service. You can say SVC represents service, and this is a prefix that will be common for every DNS name. Okay, and the 80 is the port number of the service on which the Kubernetes service is configured. If you see here, the Kubernetes service is configured on port number 80 TCP. Right. So if you go here to this particular, and this is an endpoint for the Prometheus server URL where the Grafana will be getting the metrics from actually. Okay. So you need to click on save and test. You can see that successfully queried the Prometheus API, and it is getting the metrics actually. Okay. Now the Prometheus is added as a data source for the Grafana. Okay. Now you can create some good dashboards in your Grafana. Let me show off creating one. Okay. Let me click on this one. Okay. You need to click on create a dashboard. So Grafana will give you some default dashboards. You can also import the dashboard by going to Grafana. Okay, Grafana. Okay, Grafana default Kubernetes dashboards, something like this. Okay, Kubernetes dashboards for Grafana, for the Grafana labs. Okay, you will be getting the default dashboards. You can copy the dashboard ID, something like this, 18283. You can copy this ID and you can import the dashboard in the Grafana. Okay, import dashboard, something. Click on this import dashboard. Let's the dashboard. Okay, this is going to be imported dashboard. Okay, save. 1 second, very good. Okay, you need to click on this ID, paste this ID here. You just need to click on the load symbol and you need to add. No, in the course, we are going to use the custom dashboard, not the default dashboard. Okay, we are going to create the panels, but not here actually, but because it's a matter of time. And yeah, okay. Now let me click on import. Data source is going to be the Prometheus, and the Prometheus import. You can see that all this being collected from the Prometheus actually. Okay, now from the Kubernetes cluster, you can see that here core DNS cache size and CPU utilization by namespace. Okay, you can see that all these things. These are the different metrics that are being collected. Okay, you can also number of namespaces. Okay, something like this, and you can also click on this, and you can also click on edit, and you can also check the things that are being there. Running pods are 17. Okay, all these things, metrics that you can monitor actually, something like this. Okay, this is how you need to import your dashboard from the default dashboard from the Grafana. But how you can create a, let me click on save dashboard. So I don't have to add any notes. Let me click on this dashboard. Let me delete this dashboard, which is imported, saying something like this. It's not required for me. Okay, delete. Okay, so let me click on close this, and you can also create a custom dashboards. Let me click on new. Okay, new dashboard, and you can click on add visualization, and Prometheus is a data source, and you have something called, we will be exploring all these things in the course, but not now because it's lack of time and all. Okay, you can build the query using two ways. One is builder, and you can directly write the PromQL query, something like this. Okay, and the Prometheus is going to be the data source. I want to monitor per CPU pod, per pod CPU usage. Okay, let me go here, and let me go. We have collected some PromQL queries. Let me copy this particular place, copy this one, and we can go here to the Grafana and put your PromQL query here, and you can click on run query. Okay, your data will be there as part of this particular thing, and you can add a title for this panel. Okay, per pod CPU usage, USAG, something like this. And there are many types of graphical user interface that the Grafana provides. It's a time series and the bar chart, or the stats, or the gauge, okay, or the whatever the bar gauge or table. Okay, let me take this time series database, and you can also use the legend to be disabled, something like this. Legend means these are the things, which namespace and which pod that will be listed under this. Okay, if you click on this one, it will be listed when you put your mouse on the particular graph, actually, something like this. Okay, I want legend to be uh, disabled, and we will be exploring all these things. I don't want to explore it here, but yeah, fill opacity, something like this. We can do some shadings for our graphs, something like this. Okay, let me put something visible, something like this. Fill opacity and the solid, all these things. Let's fill this threshold. Okay, we will be seeing what is this and all. So let me click on Save dashboard, and let me give the fine. Let me give the dashboard title as dev. Okay, let me give the dashboard title as dev and save. Click on this, and let me, yeah, this is the dev dashboard. If you click on the dashboards now, let me just click on save dashboard. That's fine. Okay, saving initial changes, something like this. Okay, click on save, and you see that this is an imported dashboard. This is a custom dashboard that we have created. If you click on this is our panel that we have created in this particular dashboard, something like this. And you can also differentiate this dashboard with the row. You can click on add row and build a row title here. You can click on a row title. These are pods, PODs, something like this, pods, and update this. And this contains this particular folder contains all the pod related data. And you can also, once again, let me add one more visualization. Okay, and you can go to the prompt where queries, pod memory usage instead of that. Okay, let me take this one. Okay, let me go here, put it here, and then this query or panel title. The total number of pods that are running is 17. That's what it means. And let me take stats number, because I need only number of pods running in the cluster. Okay, number of pods running, number of pods running, something like this. Can go down, and let me click on once again. Save dashboard. I'm going to save this dashboard saying that added panel per total pods running, something like this, and click on save it. Yeah, see, all these things we are going to explore in the sessions, but not here. But yeah, that's fine. Okay, let me go to the dashboards now, dev, and you see that there are two dashboards now. One is number of pods running, and the pod CPU usage, something like this. Okay, and you can also let me create one more dashboard. Save this dashboard. Add panel for number of pods in cluster, something like this. I click on save. Okay, now let me add one more panel, add visualization. Basically, you very important thing is you need to know the prompt your queries, actually. Okay, so something like this. Yes, you can also get the StrongQL metrics. This is something called metric that we call it as, and this queries you can find it on the PromQL. Where there are many documentations available, not on the PromQL for use actually. Okay, let's go to okay, this one. Let me go to number of pods per namespace. Let me go here. I want this also need to be display something like this. Let me click on done. But I don't want to. Yeah, but I don't want to this one in the time series. I want in a pie chart, and I want this to be as a donut, something like this. And in the cube system namespace, there are 10 pods, and in the Prometheus namespace, there are 6 pods. In the Grafana namespace, there is a 1 pod, something like this. And I want to view the panel title as pods per namespace, ns, something like this. Okay. You can also provide the description number of pods per namespace, something like this. Transparent background, you can also make this as transparent, something like this. I want to make this one single as transparent one. Legend, you can also disable this one, and you can also put this one something like this as a table, as a list. Okay, whatever, there are many things that are being shown as an options here. You can click on save and added added PANEL panel for number of pods per namespace, number of pods per ns, something like this. Okay, let me click on save, and you have your dashboard here. Okay, you see that here. This is the dashboard for number of pods per namespace, something like this. Let me go under the pods, because all these metrics, you see that all these metrics are regarding pods, CPU percentage, and the number of pods running in all the cluster, and number of pods per namespace. You see that here, something like this. Okay, and something like this. Put this one, something like this. And this. Okay, like that, you can also create one more thing that is called nodes. Let me click on add row title. I want to make it as nodes. I want to relate it to nodes, and let me click on update. These are here. I want to add the related to nodes, add visualization. You need to fetch out the PromQL query, CPU usage across all the nodes. Let me copy this one. And the CPU usage should be in the time series. Okay, you can also use that, but different things. But yeah, run queries. Okay, you see that there is something called query inspector. This is it will show you whether the data is being fetched from the Prometheus or not. This is something like that actually. Okay, you need to, yeah, that's okay. Okay, so this is going to be the time series, and this one. CPU usage per node. You say we have 2 different nodes. These are the 2 nodes that we have, and the CPU usage per node, CPU usage per node, something like this, and the description, node CPU usage, something like this. The transparent, if you want to make it transparent, you can make it or not. So you can also fix the legend. Okay, if you yeah, whatever you want to do, you can do. And let me click on save the dashboard, and let me make it as changes added PANN panel per node CPU usage, something like this. Let me click on ADV, something like this, and let me click on. So there are many options in the Grafana that need to be discussed, actually, sharing the dashboards and all. Who is changing the dashboard, please? Anyone are using the dashboard? Anyone are using that? Please do not, because it may affect me actually. So that's the thing. Please do not use the dashboard. Okay. So let me go back, and let me something like this, and go here, and nodes. Okay. These are the pods, and these are nodes, and these are node CPU utilization percentage. And let me take one more panel as a last panel. Okay. Visualization. Let me go here, and memory usage also let me take. Let me go here. Okay, let me click on run query. It is a memory usage, and let me remove this one. Nodes, memory usage per node, usage per node. Okay, let me click on this one, transparent. Okay, let me go to the bottom, and it's to legend, actually, this one. Let me click on save the dashboard, and add a panel per node dot, and click on save, and Okay, let me go back to the dashboard, and this is for the node. Actually, let me do this out like this now. Something like this. Okay, so something like this. So these are the dashboards for nodes, and these are the dashboards for pods. You can add multiple things like this. You can also add the custom metrics when you are being collected. You can also decide refresh time interval for every 5 seconds or whatever. I want to query the see this is something called for every 5 seconds. This Grafana is going to query the Prometheus in order to collect the metrics. That's if you configure 5 seconds, something like this. Auto refresh for every 5 seconds actually. Okay, you can click on the save the dashboard, then click on save the dashboard. Okay, this is a dashboard that we have created. It's a custom, but there are many things that need to be discussed. Okay, there's a new course that are going to be started with Docker, Kubernetes, and Jenkins and AWS by me in DURGASOFT soon. You can also explore that in that course actually. Okay, that's many things that we will discuss actually. So we have snapshots that need to be created, playlists that we have. What is this playlist? Is something like, let me create a playlist. Okay, let me give the playlist a name. Interval is going to be okay, 5 seconds. Okay, I'm going to be select this dashboard, and I'm going to select another dashboard, something like this Kubernetes dashboard. We have created a custom one custom dashboard, and the other one is default dashboard that we have. And let me click on save, and you can click on start playlist, and you can also okay. What is this playlist is like? Playlist means what is a playlist? If you if you if you want to continuously play your songs in your whatever geo song or whatever, it's continuously playing the songs, right? One after the other, one after the other. Like that, here also it will be continuously changing the graphs between the dashboards. Actually, for 5 seconds, one dashboard will be visible, and the other 5 seconds, one dashboard will be visible, and the other 5 seconds, another dashboard will be visible. Actually, you can connect your TV to this particular place and share your playlist there. And I want to share it as normal. If you see something like this, okay, yeah, you see that here. Okay, yeah, for 5 seconds that will be there. For 5 seconds it will be there, and that you can monitor your cluster very perfectly by creating playlists. Actually, you can share this one with your TVs, and you can monitor your clusters there also. In the last company that I have, they have created one. They have purchased one big TV and shared this playlist with the TV, and they have put monitor like TV in front of every one of us so that we can monitor the Kubernetes cluster continuously whenever we walk through that particular TV, right? So that's how we did in the last company. Okay, so there are many things that we do in the Grafana and Prometheus. Actually, we can create the alerts and playlists and the sharing the dashboards, snapshots, all different things. But yeah, that need to be discussed in the course, but not here because it's lack of time and this is just a webinar. That's the thing. That's a entire webinar. And now it's time for Q&A. If you have any questions, please do ask. Any questions, please, anyone has. Anyone has any questions? Or all clear, or just
Thank you very much.
yeah,
Sunil.
yeah, yeah.
Okay.
Yeah, Manikandan, I'm presently teaching Docker, Kubernetes, Jenkins, and AWS in DurgaSoft. If someone is interested, you can also go through that content and you can join the course actually. Okay, so that's completely your choice. That's a thing. And I am planning to conduct workshops on a regular basis. I cannot tell you the time, but yeah, if I conduct the workshop, you are going to get the notifications to your WhatsApp or the emails. If you are willing to join, please do join our workshops so that we can interact always. Okay. Thank you. Thanks for joining this session. I hope I have delivered the content in a better manner. Okay. I hope you people are satisfied, right? Yeah, I thank you for giving your time in this such Sunday day. And yeah, thanks everyone, and I'll meet you soon. Anyone have any questions? Yes, the webinars will all be only on weekends. Okay. But the sessions will be in the normal days. Thank you. Thanks for everyone. I'll meet you in the next class. Thank you. Bye.
Thank you. Bye.
Bye.